Hello, everyone. Thank you so much for joining us in person or online. It looks like we have quite a few participants online. And my name, like Andrea mentioned, my name is Maria Silveira. I'm a professor here at the Range Cattle Research Center. And today we're going to talk a little bit about biosolids. Some of you may have heard me talking about biosolids, so I decided to change a little bit. Instead of showing results from my own experiment, I decided to take a more broader perspective on this presentation and talk about issues that affect beneficial reuse of biosolids in the US. So I'm sorry if the title of my presentation will be a little bit a mismatch with what I'm going to be talking about, but hopefully the information will be useful for you. And again, feel free to ask me questions. I'm gonna leave my email if you don't have a chance to ask me questions. Please feel free to reach out to me after the seminar. So I want to start by, I think this is pretty intuitive, but has anybody in the room think about what happens when you flush your toilets or you shower? Where that wastewater goes? We're very fortunate. Let's take a minute, let's pause right here. Depending where you're coming from, and we have a very diverse group, a lot of international students here. Most likely, it goes directly into a water body. Half of the world population doesn't have basic sanitation, access to basic sanitation running water. So we are very fortunate that we're dealing with some of these issues, because that implies that we do have a sanitation system that treats the water that is discharged from our households. So if you are lucky enough to be in a developed country like we are, once you flush your toilet, and here's the residential wastewater and commercial wastewater, once you flush your toilet or you bathe or you use your dishwasher, the water goes into a centralized wastewater treatment facility. So there are many around us, and they all follow pretty much the same steps. So once the water gets there, there's a initial screening, just removal of debris that comes along with that. And you can, I know you all are thinking, you have that picture, very pretty stuff in your mind. I'm gonna show a picture of what that actually looks like, but imagine that stuff that comes out of your toilet, gets to the wastewater treatment facility. There's a initial screening. If you Google, some of the wastewater treatment facilities will tell you the stuff that they catch in this first trash removal. It's pretty interesting. I think maybe I'm the only one who finds this stuff interesting, but it's very interesting to see what people flush in their toilet, all sorts of things, tires, and anyway. And then after that first screening, it goes through another physical separation process that's generally called primary treatment, that involves flotation and, flotation and gravity sedimentation, and then also where all the fat, imagine everything that we flush, is all the fat and the oils are removed. I'm going to show a picture. And then it also separates that liquid from the semi-solid. The liquid is the effluent. The effluent is directly discharged into a water body. So of course, it's further treated before it's discharged, but the effluent goes into a water body. The semi-solid that stays in that settling tank here. Let me see where my mouse is. The stuff that gets on the bottom, that's the sewage sludge. So even though the title of this slide is biosolids versus sewage sludge, people use those terms interchangeably, but that's incorrect. So the sewage sludge is that stuff that's raw, hasn't been fully treated. And it's not the same as biosolids. Biosolids is material that it's being fully treated and can meet regulatory criteria to be land applied. So in a lot of countries, they use those terms interchangeably, but it's important to make that differentiation. So that sludge, the sewage sludge, goes into another process. It can go to a secondary, tertiary process. Then it finally becomes this product that we call biosolids. And the biosolids has a number of benefits when it's beneficially reused. And that's where most of the presentation is going to be focused on. So just also in terms of giving you an idea how much, once you get that wastewater gets into the settling tank, about 90%, 99% of the volume it's just water. So we're talking about that 1% that we flush, and it's this semi-solid. So last year, I had this opportunity to go to this wastewater reclamation facility, and I was FaceTime my kids because I thought it was so cool. I was in one of the largest wastewater treatment facilities in the world in Chicago. It's called Stickney Water Reclamation Plant. My kids were not quite as excited as I was, but this is how the wastewater looks like when it is entering the wastewater treatment facility. So I don't know what you had in your mind when you were picturing that toilet water being flushed, but this is how it looks like. I took this picture, I'm standing right here, and it doesn't smell quite as bad as I thought. And you don't see anything solid moving along with the water. So to me, maybe this is too much information, but that's pretty impressive. And the amount of water that they treat, the wastewater they treat on a daily basis is incredible. So it's from the engineering perspective, it's a pretty interesting facility to visit. So this is the primary treatment. Can you all see my mouse? I'm not sure if you can, oops. So maybe I don't want to point because then the focus on the Zoom won't be able to see. So this first picture on your left-hand side is the primary treatment where the oil, so there's some blades here, they're scraping all the fat, and those blades move very slowly and scrape all the fat that floats on the top. This is the digestion, where the anaerobic digestion or aerobic digestion happens. And I also want to, at the end of my presentation, I'm going to show 2 short videos about this nutrient recovery facility that this water reclamation plant has. So basically converts biosolids into this granular fertilizer that can be used by farmers. Another interesting fact, and this is a copy from one of the fact sheets from the Metropolitan Water Reclamation District of Greater Chicago. If you flush a toilet in the Great Northern Lake, it takes about 8 hours to get to this facility. Most likely you'll end up in this facility, Stickney Water Reclamation Facility. And once it gets there, it takes about 8 to 12 hours for the water to be discharged. So it's a pretty incredibly fast process on how those things are moving along inside the treatment plant. So that Stickney facility was just an example because the large scale. I'm gonna go back to that, but let's focus on Florida now. So there's this US statistic that tells that each one of us generate about 0.16 pounds of dry weight sludge per day. So the sludge is about 80 to 9% water. So imagine it's a considerable amount of sludge that we all produce. So it's a societal, how we deal with that. So for those who are trying to make the math, and if you work in metric system, this is about equivalent to about 25 kilos of dry sludge per year that each one of us generate. So of course it's difficult to manage once it's treated. What do you do with that stuff? So Florida is a highly dense populated state. So we have about 21.5 million people. We still have about 30% of the Florida population relying on septic systems. So about 70% rely on centralized sewage system. I just saw a spelling error here. So about 70% is rely on the centralized sewage system. That equals to about 400,000 tons of dry material per year that's generated. And again, the question is, what do we do with that material? In Florida, we produce 2 types of biosolids. Those are called Class B or Class AA. There's not much, the way they are classified as Class AA or Class B, it depends on the amount of pathogens. And also they have metal levels, but you're gonna see there's not much difference. So mainly the pathogen levels. So the Class B is the minimally treated material that can be, meets the requirement to be land applied. Class AA are stuff that essentially has no pathogens. There's no site restriction, so you can apply to your garden. You can grow anything. You can go to Home Depot and buy Class AA biosolids. Sometimes you don't even know that you are buying because they're also used as a filler in commercial fertilizer. So most of the land application, historically in Florida, we use Class B. So because it contains some levels of pathogen, there's some restrictions. For instance, for pastures, there's a 30-day grazing restriction. Why that it exists is to minimize the potential exposure of those animals to the material that's being recently land applied. It has nothing to do, I wanna reemphasize that the classification of Class A and Class AA or Class B has nothing to do with nutrient content. So it doesn't, well, in other words, doesn't mean that Class AA is less likely to leach phosphorus. That has nothing to do with that nutrient composition. So in terms of regulations, Florida is probably one of the most heavily regulated states in terms of land application of biosolids. We have federal laws, we have state laws that are much more stringent than the federal laws. And most of the counties in Florida also have some sort of local ordinance. So it's, if you compare, for instance, with other organic waste material like manure, animal manure, manure doesn't have many regulations. Biosolids are heavily regulated. So I mentioned 400,000 tons of dry material per year. What do we do with that stuff in Florida? And this is a map. You see this stats is relatively old, 2013, that was put out by Florida DEP. About 2/3 of those material, that 400,000 tons, is beneficially recycled either as Class AA, that's usually bagged and marketed as fertilizer, or the Class B material that's land applied. And the land application is mainly on pastures. It used to be in citrus, but now we don't have many citrus groves anymore. So mainly, historically used to be land application of Class B material to pastures. Why I'm saying, and about 1/4 goes to landfill, which is definitely not a good, not the best from an environmental and also economically perspective, the best destination for this material. The reason why I'm saying that historically, this is how we manage, because some of you, especially producers or environmental agencies, folks that are watching this presentation online, many of you know that we changed, some of the state regulations were changed in 2021. So they became effective, those changes became effective in 2021. So I suspect, I don't have more recent stats, but I suspect that pie chart is gonna look quite different because of more restrictions on land application of biosolids. So how we compare with the rest of the US, pretty much about the same. If you look at management of biosolids in the US, about 50% is land applied, the majority to agricultural lands, but there's some use on mine land and reclamation. So what makes this material attractive to agricultural lands? What is in biosolids? So let's start with the good stuff. And probably the best of all, the icing on the cake, is the organic material. So the biosolids contain about half or to 70% of organic material. So when you add the organic material to extremely sand soils like Florida soils, it provides a lot of benefits. It also contains a lot of nutrients, especially nitrogen and phosphorus. You look at this as mean concentrations and the range. Doesn't contain much potassium. So for warm season grasses, for producers, forage producers, they have, depending on how they are managing that pasture, they probably have to supplement potassium fertilization with commercial fertilizer, because biosolids don't have a whole lot of potassium. The issue that becomes a problem, it can become a problem, is that when you look at the nitrogen to phosphorus ratio, it's not balanced with most of the crops require. So in other words, if you repeat the biosolids application for many years, you can have a potential to increase phosphorus concentration in your soil. So if the application rates are based on the crop nitrogen requirement, you may be over applying phosphorus, that over time, many years of the over application can result in phosphorus accumulation. And that's where most of the issues in Florida are focused on, that nutrient imbalance. But I'm gonna show you some data whether demonstrating whether that happens or not. So in terms of one of the concerns, my relationship with biosolids started in my master's degree. So I'm not gonna say how many years ago, but it's a couple of decades ago. My PhD thesis was based on heavy metals in biosolids, and I was using biosolids from Brazil. So I came to the US and I went to the University of California, and my professor looked at me, why you wanna work with heavy metals in biosolids? We don't have heavy metals in biosolids. So it's important to also understand that discrepancy, where you are coming from. A lot of countries like Brazil, they mix domestic and industrial waste into the same, so the material can be heavily contaminated. So if somebody's doing a literature review and looking at issues affecting biosolids in countries where that happens, heavy metals are maybe still a concern in some countries. In the US, like I showed that first picture, the domestic wastewater is treated separately from industrial. So in terms of the federal government, it's called Part 503, they established the ceiling concentration limits for different metals. And these are the concentrations that the maximum concentration that a material can have. And if you look at the third and fourth column, these are averages of materials that are produced in Florida. Again, this is a relatively old stats, but things have not changed that much in terms of biosolids composition. So you look at AA, class AA and class B, and the nutrient and the trace element concentration is fairly low compared to the ceiling limits. One might argue, well, class B is slightly higher, concentrations are slightly higher than class AA. And the reason for that, a lot of class A materials, they also are mixed. They're composted with other, so there's a dilution factor. So they mix yard trimmings and other stuff. That's why it's slightly less. But compared to the federal limits, it's fairly minimal. So that's why we really have metals is no longer a concern in the United States, because concentrations are, and if you compare these concentrations with like background levels, what you have in a natural soil that never received biosolids, oftentimes biosolids have lower concentration element concentrations than a natural soil. So it's many times it's below what we call background levels. But again, there's a lot of misconception out there that biosolids are heavily polluted materials that contain pathogens, they contain microplastics, they contain pharmaceuticals, and a lot of attention now is being focused on this PFAS, which is a group of substances. So it's not one compound, but it's a group of many different compounds. You may have heard that forever chemicals. So these chemicals have been around, and I'm gonna very briefly mention about them because first of all, it's not my area of expertise, but because it's such a hot topic related to biosolids, I wanna mention. These materials have been around for 50 plus years. We all use in our daily lives. Ladies, if you're wearing foundation, you were exposed to PFAS. If you hopefully floss your teeth yesterday or this morning, you were exposed to PFAS. So anyway, the exposure levels that you're gonna get from biosolids are incredibly lower compared to things that were exposed in our daily lives. And I'm gonna show you some data about that. And like I said in the previous slides, most of the contaminants concentration, so biosolids do contain all these things that I just mentioned. However, you look at the concentration levels, they're usually lower than the background. So you look at pristine soil, they also gonna have some microplastics and PFAS, because those are things that we're using in our daily life. So they end up in the soil. But the relative concentration are very similar to background levels. So I wanna give an example. A lot of the Asian, how we determine, how the ceiling concentrations were determined. How we know that 7,500 parts per million of zinc is the maximum concentration. So what EPA does, and a lot of other agencies does, they use this tool that's called risk assessment. So to understand the likelihood of an individual that's highly exposed to that contaminant to suffer any harmful effect. So like I said, it's a scientific process that takes into consideration two things. The exposure, how much a person, or it can be any ecological receptor, a fish, a plant, a microbe in the soil, has contact with that particular contaminant. And the second factor is how toxic that contaminant is. So the Part 503, which is the federal regulation governing biosolids, took into consideration this risk assessment, trying to identify what will be the worst case scenario, or the individuals that are more susceptible to that continuous exposure to these pollutants. And this is a very long process. There are different ways of exposure. I'm just gonna mention but this is an extremely simplified way to look at a risk assessment, but I wanna just give you an example. I don't wanna spend 30 minutes talking about risk assessment. So this is hopefully you guys can see that, kind of small, but what I'm showing, I also have to put what I'm showing on this, on your top left-hand side, are two different scenarios where first one, we're composed biosolids. The other one is regular biosolids. So composed biosolids and regular biosolids. And there are 4 individuals that are being exposed. And again, this is a worst case scenario. I don't think For instance, let's look at this one. I'll read it for you in case you, can you all see? No, no, okay, I'm sorry. Yeah, bad example for students. Don't put visual that people cannot see. So I'm gonna read just an example. What this, you see the gloves? So this will be simulating what a gardener. And the assumption is that this gardener weighs about 176 pounds, so a normal weight for probably a male gardener. And this person, the parts of the body that are exposed to the biosolids: head, hands, forearm, lower legs, and feet. So basically, get a visual. This person is rolling on the biosolids. And this person is guarding at least 1 day a week, every week for 20 years. And remember, it's not a normal gardener. For some reason, he or she likes to roll on the bicycle. So that's the pathway of exposure that this risk assessment is simulating. The other are different examples. For instance, this is a child. The second one is a child that's playing 52 days per year for 6 years and same body parts. So this is kind of unrealistic. I don't think a gardener is, maybe the hands, maybe some other body parts, but I don't think the head is going to be exposed. But anyway, in this simulation, the risk assessment, they're simulating what will be the worst case scenario. And also takes into consideration how much soil is being ingested. I'm not a gardener, but I never eat soil voluntarily. But this risk assessment takes into consideration that the person or the child is eating soil with biosolids. So what they are trying to do, and there's other two scenarios there, agricultural worker that's spreading biosolids, so very high exposure rates. So anyway, you get the principle, right? How long will it take for those different individuals to have the same exposure to different contaminants as they were compared to some of these things? And you cannot read, right? Can be honest, no, you cannot read. So this first column, I'm sorry, I apologize for the bad visual. So this one, if you take 1 tablet of ibuprofen, how many of you has taken ibuprofen in your life? Everybody, right? Yes. So if you take 1 tablet of ibuprofen, 1 time, 1 tablet, what will be the equivalent of the same exposure? So biosolids contain ibuprofen. Wow, so harmful. So for instance, how many years will it take for you to get the same exposure rate as taking 1 pill by mouth every day? So, and these are the different individuals. So the one that will get exposed faster to the ibuprofen will be the agricultural work. And you'll take 24,565 years to get to the same exposure rate as taking 1 pill of ibuprofen. Another example here, I'm not gonna go over, it's just to give an idea what a risk assessment can tell you. Is the likelihood of causing a harmful effect to that individual that's highly exposed. So the last one here, if you wash your hand with tricloclosan, so any antimicrobial soap contains this chemical, guess what? Biosolids also contain. So if you wanna portray a very chaotic message, you can say, wow, biosolids contain all these chemicals. But yeah, at what levels? Concentrations are so low that compared to what we are exposed in our daily life, it means nothing. So if you wash one hand 1 time, how many years will it take for those individuals to get to the same exposure rate? And I think again, the agriculture work is the one that's going to be most sensitive. It will take 216 years. So this is the approach that a lot of the agencies, and of course, this is an evolving process as scientific data becomes available, the toxicity information becomes available. They re-evaluate those risk assessments. But this is just an example how that process, how do we get to those ceiling concentrations? And so a lot of states, we're going to talk about PFAS, a lot of states rush into getting those ceiling maximum concentrations without much science behind. And that can be a concern because some of those levels can be unattainable. And it makes no sense when you look at the other pathways of exposure. For instance, I mentioned the makeup that some of us are wearing. So anyway, what is being done in Florida in terms of scientific literature? I didn't want to spend a whole lot of time talking about specific research efforts. I'll be happy to discuss this, but the benefits of biosolids has been well documented in the scientific literature in Florida and elsewhere. So there's a lot of benefits in terms of crop production, soil health, replacing nutrients instead of using inorganic fertilizer, replacing nutrients with biosolids. At the same time, there's also no peer-reviewed scientific literature showing any evidence of disease or any harm effect associated with land application of biosolids. So why peer-reviewed publication is important? In this presentation, I can put any table, any number, and tell you that's the number that I got, and you're all gonna believe. So the peer review process is the process by which my colleagues evaluate what I've done in a scientific way, and approves or disapprove my work. So it's a way to validate the science. If it's not published in a reputable peer-reviewed journal, it means it's just my opinion. I could have made up that number. But if it's published, that doesn't imply that 100% of the published literature, but there's higher chance. It's a way that we ensure that's unbiased and it has a scientific rigor. So that's why I'm focused on the peer-reviewed literature, not something that so-and-so did or published in a magazine. That's different. And many of us in Florida, many of my colleagues, some had dedicated their entire career. For instance, Dr. O'Connor dedicated his entire career researching biosolids. So there's plenty of scientific evidence. If you look at scientific literature, that's not the goal today, but specifically for pastures, because most of the audience, most of the users, historically being forage producers, cattle producers, they used to have access to biosolids. If you look at how much work has been done, and use those words, keywords, biosolids, I just picked some random words, and plug those keywords into the scientific literature, I came with about 28 papers. This first one you probably cannot see, but it's a paper published by one of my former PhD students, Ying. The most recent one, also published by another student, our student, Leandro Vieira. So we are contributing to the scientific literature on this topic, but what I want to say is that there's plenty of studies demonstrating the benefits. I'm going a little bit slower than I thought. I get excited and I get sidetracked. I also want to mention this group. So this is the work that some of us, and that list of individuals from Florida by no means is an inclusive list. So there's colleagues that are doing biosolids and didn't mention her name, I apologize. But anyway, there's a lot of folks in the country that are also looking at both the beneficial reuse of biosolids and some of the potential concerns, whether it's pathogens or PFAS or contaminants of concern. So I'm honored to be serving now the chair of this group. This group is called W4170. It's a multi-state group. They were formed before I was born. This group started in the early 70s, and now we have about 50 scientists from about 30 states. So people with different backgrounds, different areas of expertise that are looking at different aspects of biosolids application. There's also individuals from the biosolids industry that participate in this group. So this picture was taken in Chicago and this is just a part of the group, not the entire group, our annual meeting in Chicago last year. So why I'm mentioning this group? Because those are the experts, not only in the US, but they're internationally recognized by their expertise in biosolids. They provide the scientific basis for EPA to develop Part 503. So any questions, there's no better expert, there won't be any better group to answer than this group. And they all focus on, they're not advocating for any side for biosolids use or anything. So they're using science to address some of these concerns. And again, it's a societal problem. We're all part of the problem because we're all generating this material. I'm gonna go over, these are different reports that have been published over the years. And I'm gonna talk about individual ones, but very important contributions to the scientific literature showing that the current regulations, federal regulations, are protective of human health and the environment. So there's one that was published in 1996. They did a very extensive literature review of all the issues related to land application of biosolids and whether those regulations were adequate. And the conclusion was, yes, it was. So a couple of years later, there was another report also published by the National Academy Review. So those are very reputable individuals that are writing this report. Also that essentially showing the same thing. I'm not gonna go into details, but I wanna very briefly mention, because this is more recent, this is 2018, the Office of Inspector General, OIG, issued a report, and the title of this report is on the bottom of this slide. Essentially, the title is EPA enabled to access the impacts of unregulated pollutants in land applied biosolids on human health and the environment. So basically, it was saying that the regulations were not adequate to protect humans and the environment. So the same group, W4170, wrote a rebuttal. And also they did a very similar process. They went through the scientific literature looking for evidence that those claims were actually true. And the conclusion was that the OIG report was inaccurate. And this is a copy from the W4170. Those are not my words. Was inaccurate and alarmist. But they also pointed that some pollutants of concern deserve some further research. So initially there were OIG identified 352 pollutants that were found in biosolids that didn't have regulation. And the conclusion was that a lot of them actually had enough scientific data. So anyway, the report, if anybody's interested, this is the PDF. So why I mentioned, hopefully I'm convinced by now, there's scientific literature is pretty robust in terms of supporting the benefits of land application. Why these obstacles still exist? And I was talking to Jim Handley before the presentation, and he mentioned this, is the issue, malodor. It doesn't smell good. It doesn't smell good because, especially when you apply, when it's fresh, there's a lot of sulfur components. Our noses are very effective at detecting sulfur at concentrations, very low concentrations. So it doesn't imply that because it smells bad, that can cause any harmful effect. Ammonia also smells bad. So there's this discrepancy. People associate the bad odor with human toxicological effect. And there's no scientific evidence that those things are related. Dr. Sally Brown, she's from University of Washington. She wrote a very nice article about science of odor. And the title in her article has a picture of Chanel 5. She talks about this perception. I have extremely powerful sense of smell. So I can attest that if it's unpleasant, you're gonna associate with some negative, but it's mainly psychological. So as individuals or land apply, of course, it's our obligation to minimize. It's more like a nuisance than an actual environmental, human health concern. And the misinformation, I think probably this should be the most important one, the yuck factor, because we know that most folks don't seem to have an issue with animal manure. If it's a garden has been fertilized with cow manure, people are fine. But now if it's something that's from humans, even though it's been highly processed before it gets there, people have this yuck factor. So it's very difficult to overcome that. And there's a lot of misinformation behind all this, like I said, contaminants. Pest mismanagement, I think this is very peculiar for Florida because in the past we had areas where biosolids was over-applied, lime stabilized biosolids. So I think that perception that land application doesn't follow agronomic rates, it's just people dumping a lot of material for free. I think that maybe was the case in the past, but it's no longer the issue. I mentioned that there's federal, state, and local ordinances that producers have to follow. And the uncertainty, the fact that scientific literature is still, the scientific community is still trying to come up with numbers for some of these emerging contaminants. Very briefly, these are relative concentration of PFAS. So where PFAS comes from? Anything that non-stick surface, Teflon pans, floss that you glide through your teeth, lipstick, mascara. This is food packing, pizza box. This is the concentration of various materials that we're exposed in our daily lives, and this is biosolids. Yeah, I think biosolids contain PFAS, but so does foundation. So in a much higher level. So I think it's a matter of how you want to portray the message and also use common sense. So how we deal with that disconnect? There's a lot of benefits. It can replace inorganic fertilizer. Imagine the environmental footprint associated with mining phosphorus, for instance. We all see the mining around this area here. If you have a material that's a waste material that you can effectively recycle, would be a much better approach. So the only way we can combat that misperception is by doing science, conducting long-term, and we need field experiments. This is also a sentence that I got from copy verbatim from the OIG report. A lot of the studies that has been done under laboratory conditions, they mimic unrealistic concentrations. So they might have a value. Those type of studies might have a value in terms of understanding the mechanism, but when it comes to practical implication, we have to be careful how we interpret, because if a material has 1 parts per trillion, and in the lab you simulate something that has 10,000 more, what is the practical implication? So we need actual field studies to address some of these issues. What we're doing here at the research center, that's what I said, I don't want to spend too much time. We were fortunate enough to receive funds from the Florida Cattle Enhancement Board funds to establish these long-term plots a few years ago. So these are plots that are heavily instrumented. They were originally designed to address nitrogen and phosphorus issues, water quality, the likelihood of nitrogen and phosphorus leaching from those plots. But now we're expanding to other areas. PFAS, for instance, we're contributing to a national project that's looking at potential contamination, PFAS contamination, biosolids, amended soils. We trained 3 students. So in addition to the research, we also training the next generation of scientists that are going to be doing research with biosolids. Let me tell you, not very easy to recruit as students and tell, by the way, you were working with human poop. So it takes a special type of person to be able and willing to work with this. So first of all, very thankful that the Florida Cattle Enhancement Board funded this project. After many years now, we got a little bit of funding from other sources, but they were the first one to put money and trying to, if that's a problem, we want to be upfront. Many presentations, and I'm not going to go through. These are some of the peer review papers that came out of this study, this ONA field study. Most recent one that I mentioned, published by Leandro Vieira, PhD student, is questioning the benefits of the new state regulations concerning biosolids land application class B material. So we have about, I think I counted 13 papers that came out of that field study. And I mentioned, in addition to the publication, we also training students. So Ying, she's watching, she's gonna hate me for putting that picture, but I couldn't find a better picture of her. So she's a very, and they continue, all the students. So Ying and Leandro completed their PhD. Nikita, who is here in the room, she started last year, and she's gonna continue expanding some of the work that they've done. They're both in academic positions. Ying is a professor in China. Leandro is a postdoc in South Carolina. So they continue their training after they received that exposure here. I'm not gonna these are just some of the take-home messages from these studies, very broad, and it's a synthesis of those 13 papers that I mentioned. All the studies that we did demonstrate further agrees with the scientific literature, showing that there's many benefits associated with biosolids application. It can replace an organic fertilizer, much lower cost, much less environmental impact. Before I finish, I have 2 short videos, but I want to talk about this last bullet point here. So we did, I'm not going to disclaim the name of the place, but it was a commercial cow-calf operation that was near Important Lake. So we did a study to look at whether, and they were using biosolids for quite a number of years at a relatively high application rates. And they have to cease the biosolids application. And they were concerned, well, whether that phosphorus that accumulated in the soil was leaching out. So we did a study, and we published this, I think it was 23 or 22, I'm sorry, can't remember, showing that actually the amount of iron, aluminum, so I'm not gonna get into too much details. I'll be happy to discuss one-on-one, but how phosphorus is retained in Florida soils. We don't have minerals to retain phosphorus. So there's nothing like tropical soils where phosphorus is tied up with aluminum and iron and other minerals. We don't have that luxury here. Our soils are extremely sand. So when you add biosolids, one of the constituents of biosolids is iron and aluminum. The iron and aluminum increases the soil phosphorus holding capacity. So it increases the phosphorus levels, but it also increases the amount of iron and aluminum that's added to the soil. So in other words, you're adding phosphorus, but you're also increasing the capacity of the soil to retain phosphorus. So the bottom line of that paper was that pastures that receive biosolids leach less phosphorus than the ones that didn't have any, 50%, 55% less than the controls, where there's no biosolids application. So that's published. I'll be happy to discuss. Lastly, very short. So we know the land application is one of the strategies. We have to think outside the box. So what are the other technologies to recover those nutrients? I mentioned that the imbalance nitrogen to phosphorus concentration. So I'm going to show two very fast videos. Again, I'm going back to the Water Reclamation District of Chicago that shows this. They produce this crystal green. It's a pelletized biosolid. Pelletized inorganic fertilizer. I think the composition is 528.0. So it's struvite. So they recover phosphorus on the wastewater. In this process, they produce this magnesium ammonium phosphate nutrient. So imagine that blackish what? Oh, it's not gonna. Oh no, I'm disappointed. It's not gonna play. But anyway, what it was supposed to happen was you could see this white pellets coming out of that reactor. So they have these three large reactors. They had chemicals to promote that formation of this crystalline material called struvite that contains phosphorus. So they produce this pelletized material that is then bagged and farmers in the area can use. Much better approach than transporting wet. There's another technology that they also, this is a smaller scale. I think this is a more like pilot scale. The other one, they are bagging the fertilizer and shipping out of the wastewater treatment facility. This one, I don't know if you noticed in the previous slide, it recovers about 85% of the phosphorus that comes into the plant. So a much better way to recycle and complete the nutrient loop. So this is another technology that's called revolving alga biofilm, they call RAB, to recover nitrogen. I don't know what I did to, maybe. So it's a revolving film where the algae is forming and it's also capturing the nitrogen, and they scrape that, and then the algae is transported to a field and used as a fertilizer. That's all that video was. I thought it was cool because there you go. So the technology to recover nutrient from wastewater exists. It's a matter of cost. That's it. Thank you so much. Appreciate it. Any questions? I'll be more than happy to answer. So the question here was if we looked at the difference in plant availability of phosphorus in biosolids compared to inorganic fertilizer, and the answer is yeah, they're not compared one-to-one because I mentioned the iron aluminum, it's less soluble. So that means you cannot, if you have to apply 40 pounds of P2O5, you cannot use that same rate. One of the research that we're doing right now is to determine what is that conversion factor but yeah, it's not one-to-one. It's less available, but that's why we have environmental benefits, because it's less soluble, it's less plant available, so there's less likelihood of being transported. Yes, go ahead. Whoever was going to ask a question in the Zoom, please. There's also in the chat, if you want to.
Yes, this is. Okay, all right. The question is, I guess on one of your earlier slides, you were saying there hasn't been any studies showing negative effects to the environment from biosolids, but what about some of the recent studies by the St. John's Water Management District that they put out with some of the impacts from nutrient pollution in the Upper St. John's?
I'm sorry, are you asking me if I'm familiar with the study from St. John's Water Management District? I understood the comment.
Yes, yeah, or if you could shed a little light on it. Because
Okay,
I guess some of the earlier slides, you were saying not much for negative effects in the environment, but they showed pretty strong results showing nutrient pollution due to biosolids in the Upper St. Johns after some changes in regulation that forced biosolid applications into that region.
yes, when I made that comment, there's no, we're looking at studies that directly measured, not necessarily based on models. So I'm not familiar with the study, the particular study that you were mentioning, but yes, we're looking at things that were measured at the field or the watershed level, not calculated or estimated based on a model. There's of course uncertainties associated with that type of exercise. I'm not
Yeah,
sure.
that wasn't modeling data. It was actual grab sample data.
Okay. Absolutely. I don't know if the folks online heard, that was Mr. Jim Henley. Yes, we're not promoting over application of anything. Anything too much can be harmful. And I mentioned that there's been cases in Florida where biosolids had historically been over applied. So we are not endorsing that. We're talking about agronomic applications following the existing regulations. A lot of people say, oh, but if the regulations are not followed, well, regulation exists to guide. If individuals choose not to, that's beyond our control. But yes, we're not by no means endorsing over application. We're talking about agronomic, and a lot of the folks, especially the large scale individuals that rely on biosolids, they use extremely low rates. They don't apply every year. They come back after 5-10 years. So those are the scenarios where biosolids, land application of biosolids can be beneficial. Over application every year for a course of 10 years, of course, that's going to cause, but that's not the goal. Yes, that's exactly what I said. Yes. So the question was about the new technology. I also acknowledge the fact that land application is one of the alternatives. We have to, with growing population, for how long can we accommodate, for how long we're going to have acreages of pastures in Florida before it all becomes subdivision. So we have to look at other management options. And one of them is nutrient recovery. So what I mentioned is those are not, there's a lot of nutrient recovery technologies that exist right now. It's a matter of price. We, as a consumers or part of the problem, do we want to increase our water bill, or ultimately it's going to end up on the taxpayer to come up with that difference. So I think we are very lucky when you look at our water bill, how much it is, but if we want a better way, those technologies cost a lot of money. Yeah. It's another question. So the question was about the economic value, if biosolid is more affordable than commercial fertilizers. Historically, Class B were, they didn't, well, maybe some individuals here can correct me. There was no cost associated, just the cost of transport. So they used to be cheaper than commercial fertilizer. Now with, maybe that's may not be the same with Class AA because it involves an additional step to dry and to bag the material. So it may not be the case, but there's other benefit. It's difficult to compare 1-to-1 if you compare the nitrogen value, but you also adding phosphorus and micronutrients and organic matters. It's very difficult to make the fair economic comparison. But again, the environmental footprint, what is the energy involved in producing ammonium nitrate versus something that is already ready and slow release, plants can utilize better. And then for those who, I'm sorry, I don't know the name of the person that asked me that question. There's probably, I'm not even gonna guess a number, very strong scientific literature showing that when you compare inorganic fertilizer with biosolids, most biosolids, there might be some exceptions. The solubility of nitrogen and phosphorus, which are the main concerns in terms of water quality in Florida, is significantly less. So if less solubility, less likelihood of unintended off-site transport. So there's no question about that. There's pretty strong scientific. Again, we're not talking about over-application. If you follow agronomic recommendations. So the question was about septic systems. About 30% of the Florida population rely on septic systems. A lot of them are faulty. So that's a non-point pollution source that we don't. So the problem when we're trying to calculate budgets and mass balance, and Nikita is going to do that, when you look at the different sources, and I had a slide, but I decided not to present because it was too much. When you look at, let's look at the regional scale, Florida. When you look at all the phosphorus, and the phosphorus is the main concern. When you look at all the phosphorus sources, everything that's entering the state as phosphorus. Biosolids represent maybe 4-5% of the total inputs. So we're ignoring the 95% of the other inputs. So what are the other inputs? Inorganic fertilizer, not to pastures, because I doubted that any producer can afford hay fertilizer, but other commodities use phosphorus. And it's highly concentrated also. When you look at the phosphorus fertilizer used in Florida, there's counties where quarter of the phosphorus consumption is. Okay. So anyway, not trying to point fingers at anybody, but human demand. So living in a highly urban setting, we import a lot of phosphorus, whether it's for food or there's all sorts of things that we cannot even think about. That's what Nikita is going to do. Pet food, soap, a bunch of stuff that contains phosphorus that we're importing. So when you look at that big picture and look at, of course, biosolids, it's an end product. So it's not actually a source of nutrient, it's just the end product. When you look at that contribution, it's relatively small compared to other feed sources. Any other questions? If not, well, please feel free to reach out to me by email if you have any additional questions. I think we're gonna end the presentation. Thank you so much again for attending in person or online. Oops, thank you.
Okay, so thank you very much, Dr. Silveira. We would like to invite everyone to join us again in May on the 21st. So it's not quite like normal. Usually it's the second Tuesday of the month, but this month it's going to be the 21st of May for Dr. Philippe Moriel's ONA Highlight, Nutritional Impacts on Beef Cow Reproduction. And as always, you guys that are joining us by Zoom, whenever I share the recording with you, I will share these flyers and the sign up information for this ONA Highlight. So it'll be easy for you to go ahead and register. The first event that I would like to mention is Ranching Foundations, which is going to be held here at the center on April 26th. And it's going to be a full day program. Cost is $40 to register. And if you would like to attend, space is limited. So you're going to want to sign up soon. Herd Health Seminar is going to be held at the Arcadia Stockyard on May the 14th, and it's an evening program from 6 to 8. Cost to attend is $10, and that includes literature and the meal. And so there is a pre-registration date on that of May 3rd or $15 at the door. So if you'd like to attend, be sure and register for that one. Our annual Youth Field Day is going to be held June 27th here at the center, a full day program. Lots of awesome things for kids ages 8 to 18, along with their parents and youth leaders. Welcome to attend, and all need to register if they plan to come. This year we have topics being covered: ultrasound technology to assess carcass quality, artificial intelligence and robotics for pest control, invasive reptiles in Florida, fetal development of the beef calf, and cow nutrition. Is supplementation profitable? And then from sand to clay, evaluating soil texture. So registration opens April 15th. We also this year are continuing our t-shirt contest to decide on the design for the next year's t-shirts. So on this flyer, you can see last year's winner. Her name was Mandolin Turner. And that design is going to be featured on this year's t-shirts. And so we look forward to getting some good entries this year. If you're not already doing so, we encourage you to follow us on social media. We're on Facebook, Twitter, and YouTube and Instagram. And then if you do not get our weekly newsy emails on Friday, please take a moment to send me an email to sign up.